Being able to factor polynomials gives us a way to find x-intercepts or zeros or solutions, and also helps us find the implied domain of different types of functions, including both rational and quadratic functions more easily. Once we've factored out the GCF of a polynomial, which we learned in our last lesson, we can use different techniques that allow us to factor any remaining trinomials. One of the methods that we're going to use is the AC method. And the AC method, what we're referring to is if we assume that all polynomials can be written as the form a squared plus bx plus c equals 0, those leading coefficients is the a, the middle term is b, and the constant term is c. They have to be written in this form to use the AC method. The steps for the AC method are shown below, and let's apply them here to an example. If I have something like x squared plus 8x plus 12 equals 0, and I wish to factor it, in other words, I want to find the two terms that I can multiply together to get that polynomial. The first thing I'm going to do is list my a, b, and c values. So I will have a, b, and c. A in this case is 1. Notice there's no variable included in a, b, and c. B is 8, and c is 12. My second step, or my first step, the way it's listed here, is I'm going to multiply a times c, which gives me 12. And then I have to find numbers whose product becomes ac and whose sum is b. I typically list my factor pairs, which in this case are 1, 12, 2, 6, 3, 4. And then I want to find the one that I can add together to get 8 or subtract. And in this case, I can add 2 plus 6 to get 8. So then I'm going to rewrite this bx term using those two numbers. I can rewrite this as 2x plus 6x. My other two terms remain the same. Now I am able to factor by grouping my first two terms. The GCF is x, leaving me with x plus 2. My second two terms, the GCF is 6, leaving me with x plus 2. Those two terms should always come out with a common factor. In this case, it's x plus 2, which leaves me with x plus 6 is my other factor. And if I multiply that out, you will see that it does give me the original term. Let's do one that's a little more complicated now and doesn't have a coefficient of 1. Consider 2x squared plus 9x plus 10. Don't do anything different. I'm going to pull out my a, b, and c. A is 2, b is 9, c is 10. I'll multiply a times c, which gives me 20. And then I want to find the factors of 20 that I can combine to get 9. My factors are 1 and 20, 2 and 10, 4 and 5. Hopefully you'll be able to see fairly quickly that 4 and 5 I can combine to get 9. They both need to be positive. So I'm going to rewrite this as 2x squared plus 4x plus 5x plus 10. And I'm going to set it equal to 0. Then I think of it as two separate groups. The common factor for the first part is 2x. So when I pull out 2x from both, I end up with an x plus 2. My GCF of the second two terms is 5. And when I pull out a 5, I notice that I am indeed left with that same common term, which tells me I've done it correctly. So I can pull out the x plus 2 as my common binomial, and that leaves me with 2x plus 5, which is completely factored.